Okay, today we're going to do a quick error review, something we're going to have to do in many of the labs with some of our final trials and data. This should be nothing new to us, so I'm going to go quickly. What we have here is an equation for absolute error. We'll do a quick example of that and then move on to the more important one, which is relative error, also known to many of us as percent error. This one's the typical one we find. Because it gives us how far off we are from accepted value in the form of a percent, and that helps us understand a little bit better if we're close or far away from what the value should be. As you can see, the numerator of this formula includes the formula for the absolute error. We just divide it by the accepted and multiply by 100 to get it in the percent. So following the examples on your sheet given in class, we'll do example 1 together here, and it asks for the absolute error for trial 2, so we'll signify it like this with a subscript 2. And simply popping in the numbers, the observed is what you figured out through whatever type of trial you accomplished in the lab. So trial 2, the observed value is 23.8, and below I have an accepted value, which will always be known to you during a lab as 22.9. So we will subtract those two values, take their absolute value, and simply get a number of 0.9. as our absolute error. So that's as simple as that. But typically we like it in a form of percent, or in other words, relative error. So I'll do a quick example number 2. Let's find that relative error of trial 4. An error in this case is being found on each individual trial. At times you may be asked to average your trials and take the relative error of an average, and that's just following whatever instructions are given to you in a lab. So we're going to use the observed value for trial 4, which is 24.3, again minus the accepted of 22.9. Take the absolute value and divide again by the accepted, and finally multiplying by 100. And this will give us a value as a percentage of 6.1%. Which in most cases that sounds pretty darn close to the accepted value. Alright, we will continue on with this lesson with deviation, but as an extra note for something we're going over in class, error is a measure of accuracy. So this value we got in number 2, for example, tells us how accurate that particular, in that case, trial 4 was. Accuracy refers to how close you are to an accepted value, and error is how we measure that numerically.